Hi, this is Miss Park. In this video, we'll be solving quadratic word problems that involve maximum and minimum. Maximum and minimum just means that the best or the worst, or the highest or the lowest. So some things we might want to maximize would be, we maximize good things. So I would maximize things like area, like how much area can we fit? How big a yard can we make if we have a certain length of fence? Maximize area or maximize revenue, which is how much money we bring in, right? Some things that we might want to minimize are the bad things. So we want to minimize things like cost. We want to keep costs down. So we have the cost, we want to try and find the minimum value. Okay, the way it looks graphically is that if I have a parabola, okay, the maximum value happens at the vertex. Okay, and if it's the other way, the minimum value also happens at the vertex. So when we're doing these questions and we get some kind of equation in the form of y equals ax squared plus bx plus c, in order to identify the vertex, we can switch this to y equals a times x minus h squared plus k, which is a vertex form, right? Standard form doesn't give us much information, but vertex form does. And the way we do that is by completing the square. So whenever you see words in the question that say find the, maximize or minimize, but also find the largest or the smallest or the highest, okay, that's your clue that it's looking for the vertex. So let's do a couple of examples. So first example is going to be two numbers have a difference of 8. Okay, and then it says their product is a minimum. Find the numbers. Okay, so let's just see what this means. Let's go through the words. What it's saying is there's two numbers that have a difference of 8. I could pick two numbers that have a difference of 8. So let's say I can go 1 and 9. That has a difference of 8. Okay, 10 and 18. That has a difference of 8. Okay, and I can even go into the negatives. I can go negative 8 and 0. Okay, they have a difference of 8. So, but their product, so 1 times 9 is 9. So remember what product is. Product is multiplication. 1 times 9 is 9. So this one is 10 times 18, which is 180. It's already bigger than 9. Negative 8 times 0 is 0. So that's a small product, 0. Can I get smaller than that? Let me see. How about negative 1 and negative 9? That's a difference of 8. Oh no, that's 9 already. So that's higher than 0. So what is the minimum product you can get? I don't know. We're about to find out. But we know that the two numbers are 8 apart. So whenever we're trying to find the, when they say find the numbers, we need a let statement. Okay, we need to introduce a variable. So our first thing here is to do a let statement. Just going to write it in green, so just going to guide you through the steps. We're going to take a variable, so let's say I'm going to take n. So let n represent the first number, and it's just n for number, that's all, the first number. Now, the second number, I could find a different variable, but when we have quadratics, we really only have one variable, right? It's ax squared plus bx plus c. There's only one x. So instead of n and some other letter, let's figure out how do I write that the second number has a difference of 8 from the first number. And the way you can do it, it's actually two ways you can do it. You can say n minus 8 represents the second number. Another way you could do it is say n plus 8. I'm going to put it over here, or n plus 8. Okay. The difference is that when we solve the equations, or when we figure out the vertex and we get a value for n, the second number is going to be 8 less than that. If we used n and n plus 8, then when we figure out the vertex, the second number is going to be 8 more than that. All right, so we'll have to get back to the let statement to answer the question at the end. All right, so let's say I have my two variables are n and n minus 8. So I'm going to grab my green again. Next thing I need is the equation. Okay, so what it says is that the product is going to be a minimum. So I need to know this product. Product is what you get when you multiply the two numbers, n times n minus 8. If I expand this, I get n squared minus 8n. And this is in standard form, and I want vertex form. So we're going to complete the square. So I'm going to go n squared minus 8n, and now I have to add a fake number that creates a perfect square trinomial. So half of -8 is -4, square it, and then take it away again. So it's like I've added 0. That trinomial at the beginning, this will factor into n minus 4 squared, and then I have minus 16, which means now I can graph this, okay? First of all, can you see what my y-intercept was? Right, over here, my y-intercept would be 0, because if I make n equal 0, then there's no term at the end. There's nothing left. So here's my little sketch. There's my n, and there's my product. I know my y-intercept is 0. Okay, and then from there, my vertex is going to be 4, -16. Oops, sorry, I wrote brackets weird. Here, let's fix the brackets. 4, -16. So what's going to happen now is that actually my my parabola is going below the n-axis or x-axis. It's going to go below. So here's 4, and -16 is down here. I have a vertex here, which means I'm going to go down like this, and that means I got to come back up. Okay, so there's my parabola, and I want the vertex. That's going to give me my minimum product. What this means now is that when n is 4, I'm going to have a minimum product of -16. This is your vertex, 4, -16. So the answer to the question is, what do the numbers have to be to give the minimum product? I'm just going to write in my green here, I'm going to write concluding statement. So this is how this is going to end. And I highly recommend that you sketch the situation for every question. Sketch really helps a lot. So the concluding statement is that the minimum product, now they didn't ask for this, I'm just going to add it. The minimum product is -16. Okay, it occurs when n equals 4, and the next one, n plus 8, is going to be sorry, n minus 8. My let statement said n minus 8. Let me just double check that. Yep, there it is. I can see it at the top of my screen. The numbers are n and n minus 8. So the first one's 4, and the second one, n minus 8, is equal to 4 minus 8, which is -4. So therefore the numbers are 4 and -4. Okay, notice what happened. I found my vertex. The numbers are not 4 and -16. The n is 4 that creates the minimum product. So the first number is 4, but then the second one we said was n minus 8. So the second number is -4. And that's how you get the smallest product, 4 and -4. Okay, let's do one more example. We're going to do a revenue question. Okay, so a revenue question, and it goes like this. An entertainment company expects to sell 800 tickets to a performance. So this company can sell 800 tickets. Okay, and if they're charging $12 per ticket. Okay, and then they learn that every time they increase the price by 50 cents, then they're going to lose 200 sales. So should change this. They're going to sell 200 less tickets. Okay, so hopefully it makes sense that if a company increases the price of whatever they're selling, that they're going to sell fewer of them because it's more expensive. Okay, and you'll see some questions where it says if the company lowers the price, then they're going to sell more tickets. So hopefully that makes sense too. What's happening here is that it's saying every time they increase the price by 50 cents, they're going to sell 200 less tickets. It says that right now they're selling 8,000 tickets. If they increase the price once so that it's each ticket is $12.50, they're going to sell 7,800 tickets. If they increase the price twice, so now it'll be $13, they're going to sell 7,600 tickets. If they increase the price 3 times, so that'll be $13.50 a ticket, then they're going to sell 7,400 tickets. All right, every time they increase the price, they're going to sell fewer tickets. Okay, so let's make a little sketch here. And it's going to be, the problem is that we don't know how many times we want to increase the price by 50 cents. So I'm going to let X, oops, sorry, I wanted to write let statement there. So let statement, okay. So the let statement is this. We don't know how many times we want to increase the price by 50 cents. So let X represent the number of times they increase the price by 50 cents. Okay, now my sketch is going to have X down here and then the revenue up there. What is the y-intercept, or in this case, the r-intercept? Okay, how much money do they make if they don't increase the price at all? So if they don't increase the price at all, so X is 0, then the revenue that they make is the price times the quantity. It means revenue is how much money you're bringing in. So if you're selling 8,000 tickets at $12 a ticket, you're bringing in 8,000 times $12. So that's $96,000. That's their current revenue. So that is my y-intercept because that's before I even change the price. Okay, and now as they add 50 cents to the price, the revenue will actually go up and it'll reach some kind of maximum point where after that, the more if they keep adding to the price, they're going to sell so few tickets that they're actually not going to be making any more. They're not going to be increasing their revenue anymore. Okay, so what we want to find is we want to find this point up here. We want to find the vertex. At what point will they have the maximum revenue? Okay, so now we have our let statement. Okay, we have our little sketch. Now we need our equation. So I'm going to go equation, and it's going to look like this. We just said that the revenue is the quantity times the price. Sorry, the price times the quantity. So the new revenue is the new price times the new quantity. Okay, so the new revenue is, so the new price is this. It used to be $12, but they're increasing it by 50 cents X times. So if they increase it by 50 cents once, it's $12.50. If they increase it twice, it's $13. If they increase it 3 times, it's $13.50. So what we're doing is we're adding 50 cents X times. Okay, the new quantity is this. It started out with they're selling 8,000 tickets. Okay, but every time they increase the price, they're going to lose 200 people. So if they increase the price once, they'll lose 200. If they increase twice, they'll lose 400. If they increase 3 times, they'll lose 600. So they're really losing 200 times the number of increases. Every time they increase the price, they lose 200. And that's our equation that we want to find the vertex of. So if we expand, I'm going to go 12 times 8,000, which is 96,000, minus 12 times 200, which is minus 2,400x, plus 0.5x times 8,000, so that's 4,000x, and 0.5x times negative 200x is minus 100x squared. All right, and now I'm left with, I'm going to rearrange this into standard form. So the x squared terms first, then the x terms, and then the number. And now I'm going to complete the square. So complete the square, you factor out this negative 100 from the first two terms, and I get x squared plus, minus 16. X squared minus 16, x, close the bracket, plus 96,000. Now I'm going to take this x squared minus 16x and I'm going to add a fake number to make it a perfect square. So I go negative 16 divided by 2 is negative 8. Negative 8 squared is going to be 64, and I'm going to subtract away the 64 so I don't change the question. Now, this trinomial right here is going to be x minus 8 squared, and then I have negative 100 times negative 64 plus 96,000 Now I have negative 100 times x minus 8 squared plus 6,400 plus 96,000, which now is going to give me my vertex form, which is negative 100 x minus 8 squared plus 102,400. Okay, and so therefore my vertex is 8, 102,400. Let's go back to the picture and see how to answer the question. Back to the picture, it means that when x is 8, then the revenue is going to be 102,400, and that is my maximum revenue. So the maximum revenue occurs when x is 8. The question is, what is the maximum revenue? So I'm going to add that here. So let me just put my concluding statement on the side here, not too far down. So concluding statement is that the maximum revenue is 102,400. And then the next question, max revenue is 102,400. The next question is, what should the price be to get that revenue? So let's look at the graph. The price is not $8. The revenue occurs when x is equal to 8. But what was x? X is the number of times they increase the price by 50 cents, right? There's a let statement. X is the number of times they increase the price by 50 cents. So x is not the new price, it's how many times we're going to add 50 cents to the original price. And then so the price is equal to the original price, which was $12, plus 0.50 times 8. So we want to increase the price 8 times, which is $16. Okay, and that $16, that's the price that's going to give them their maximum revenue. Okay, so there you have it. You have an example of a revenue problem. Okay, make sure that you've got a let statement, that you have an equation written, and then you are finding the vertex of the equation, and then a concluding statement with the units, like dollars, okay, to answer the problem. All right, keep practicing. Thank you for watching.